completing the square. The last thing that we want to do this term, basically the last part of algebra, okay, is the little bit of algebra that precedes that discriminant thing that I got you to do. Remember when we were doing simultaneous equations of curves and straight lines? And I said we're going to solve them simultaneously, and what we did was we took the equation of the straight line and we substituted it into the curve one, and we got a quadratic. And before we went and tried to solve the quadratic, what did we do? We worked out the discriminant, and the discriminant was b squared minus 4ac, and what was the point of that? The discriminant told us whether or not there were, like in this diagram here, whether or not there were no solutions, i.e. the discriminant would come out to be negative, or one solution, meaning it was a tangent, and two solutions that cut it in two distinct places. That's what the discriminant told us. Okay, so what we're going to do today is we're going to sort of find out where this discriminant came from and why it's so significant. Now, this is what completing the square is. The example that I gave you over there on that board was, let's solve this. And so what we do is we get our graphics calculator to solve it for us. Fantastic. And the graphics calculator actually uses this quadratic formula thing, which we're going to derive in a moment. And it works out what the two answers are. And the two answers are, I'm just going to put them up here, 3.8 and minus 1.8. And most of the time, that's about as much about it that you need to know. You don't need to know what your calculator is doing to work it out. You just assume that those are the answers, and you go, there's x, fantastic, I've solved it, and you move on. Question is, how would you solve it if you didn't have a graphics calculator? And you look at that, and it doesn't factorize nicely. It's not one of those nice year 11 type questions where you can just go, oh, it's x, and it's going to be 7 and 1, and it's not going to work, and that sort of stuff. In other words, we can't just do a nice little factorizing job there. Okay, well, how do you think we can solve it? Rhetorical question. The answer is, to that question, is we complete the square. Now, completing the square is this process. We basically take the x squared and the minus 2x. We take the 7 and we put it over here. And then we say to ourselves, what do we put in that gap so that the left-hand side of the equals, the bit on the left-hand side, is a perfect square. A perfect square is some expression squared. X squared minus 2x. What do we put in here to make the x squared minus 2x plus something factorize into x plus a all squared? In other words, we want our next line to be this. We want x squared minus 2x, and whatever we're going to put in here, whatever we're going to add, needs to be able to be factorized into this. Okay, that is what completing the square is. Actually, it's not a difficult process. But what do we add? Now, if you don't know, does anyone know? What do you reckon? 4 is not the one? No. It's minus 7, yeah. Now we're just guessing. It's plus 1. Now look at this. X plus 1 squared is x squared plus 2x plus 1. X plus 2 squared is 4x plus 4. X plus 3 squared, x squared plus 6x plus 9. What's the pattern? What is the pattern? Yeah. You square the ends, and you effectively multiply the two guys together and double it. That's what goes in the middle. 2x, this one here, 2x doubled is 4x, 3x doubled is 6x. So here we've got, if we're working backwards, all we do is to work out how, if we've got this and we want to complete the square by adding that on, you take the 6x and say, well, the n number must be half of that, which is 3. 3 squared is 9. So that's what we add on. So you halve the middle guy and then square it. That's the guy you add on. So if we halve -2, -1 squared, plus 1. So that's completing the square. But because we've put the plus 1 on, we've added a 1 to that side, then we should add the 1 to that side as well. Excuse me. Put that away. Thank you. I saw this on, oh shit, I might hit my head on that bloody, my fat. Now, concentrate. So, this is x minus 1 squared equals 8. Now I'm awake. So, this process, where's my, that? Adding the plus 1 is the completing the square part. And of course, putting it here as well. Okay, because doing the same to both sides. Once we've got that plus 1 added, then we write it as something squared. Now this is x squared, or something squared, equals 8. If it was x squared equals 4, what are the two answers? 2 and -2 maybe? Okay. This is something squared equals 8. So what are the two answers? The something. I added 1 to this side, so I added 1 to that side. Now, the bracket with the x minus 1 in it, x minus 1 squared equals 8. So therefore, x minus 1 can equal either the positive square root of 8 or the negative square root of 8. Simple as that. We just square root both sides. We recognize the fact that there are going to be two answers because we square root it. And therefore, x is, move the -1 over there, 1 plus that, and 1, and I think you'll find that 1 plus root 8 is about 2.4. Where's our original answers? Or 2.8 in fact. Square root of 8 is 2.8, 2.8 and 1 is 3.8, there it is up there, and over here, 1 take away 2.8 is -1.8, there it is there. So using completing the square, we have got our two answers without using our graphics calculator. In fact, all we've needed is a calculator that's capable of square rooting. Any old calculator has got a, even very old-fashioned calculators have a square root button. So completing the square for us is this addition here. It's adding that and therefore compensating the right-hand side with the same thing so that we've now got a perfect square which we can factorize. That's completing the square. Okay?